A few years ago I made this two-cylinder double beam engine. And as you can see, there are a few problems with it. To make the cylinders, the pistons and the valves, of course I used this lathe. But this lathe is a taper cutter. And when I take very light cuts, the carriage is moving left and right. So I have a taper as a final part with a crappy finish. And the result is, of course, that between the piston and the cylinder it's leaking. And so are these two valves here. Which means, of course, that I was never really happy with the result. This thing was a fun build, and especially if you know that I made this on the shaper and on a not good lathe, and the result was okay-ish. But now that I have a very good lathe and a very nice milling machine, let's make this thing better. Several times in videos you hear people call this the gesso meters, or oh, it's only measured with the calipers. So, but I don't understand. If I take, for example, the valve that I want to rework, and I set my 0 here, nothing, yeah? I have 901, 902, right? Turn it off. Take the not gesso meter. It's a bit more complicated to hold, but we'll see what we can do. I need to make this micrometer stand just like Greg is doing it. It could be handy. Right, I measure here 901, 902, more or less. Not more or less, 901, between 901 and 902. So, same than the gesso meters. Other one. Exactly in the middle between 901 and 902. Let's do it again. Nine zero. 901, 902. So I don't really understand why people call this the gesso meters, because for me this one works perfectly fine, and it's not only at 9mm width, it's at whatever width, always precise. But this is of course not the topic of this video. Right, this is the valve body with two in of out outlets and the valve itself. And in here there is a little cutout. This little pipe is the air in, and this one goes to the cylinder. Imagine my piston is completely down. It means that my valve is over here. so air can flow into the body, back out and to the cylinder. The piston is moving up and this valve is moving this way. Valve closed. When the piston is completely up, the valve is over here. So the inlet is always under pressure and the inlet to the cylinder becomes now outlet, so air can come back in here and in this little cutout will escape in the open air. That's more or less the idea. And if you're interested in more details how it works, in the description below here there is a link to the build video of this double beam engine where I explain in more detail. Right, back to our project here. This thing was drilled out with 9mm. Stay where you are. 9mm. And so it is a sloppy fit. Because it is a deep hole, of course, the diameter on this part will be a tiny bit smaller than here. Tapered problem. And I don't know yet how I'm gonna clean this up, but I will figure it out. My valve is 9mm .01 here and 9.1 over here. So there is too much slop in here. As I go deeper in, it becomes a little bit more stuck. But not enough. Plan 1, make a new valve. And I would like to try it again on this lathe, just to be sure, just to see how much taper it makes, just to figure it out. If I see it doesn't work, I will use a Celtic. But first, give it a go here. And of course also because I still believe that this is a very nice little lathe to make very nice little parts. And one of the typical problems I have on this machine is that when I make small parts, the top slide is touching here the body of the tailstock. So let's take this thing off and put the fixed one in place. Finish, not good. This is 10.68 and here it is 10.52. Let's check with the calipers. $67, 49. So that's a bit over 1/10 of a millimeter of difference between here and here. Let's do the same test on the Celtic. The finish is much better. Let's measure. 958. 956. The difference of 2/100ths. And on the other lathe more than 10/100ths. Let's check with the micrometer. 59. 57. Same results. I turned the thing to size and I measured, and it is cylindric. And my little cylinder here fits, but it doesn't go further than this. Of course I could hammer it on, but that will not be a sliding fit, of course. Which means this one is tapered. And I drilled it out when I built it a long time ago. I drilled it out with a 9mm drill bit. I don't have any reamers, so only drilling. So now I have to find a way to make this one also cylindric. Let's figure something out. I have here a really cute little boring bar that could fit, but too short. So this one, not an option. I have maybe a solution or two. If I use my old printer, and I have some emery paper cloth thing here, and with this I can make a honing tool, of course. Cut a piece off and then try to hone the inside diameter of my valve here. If that doesn't work, what I also can try is I installed my little boring bar as much stick out as possible here in my tool holder. And I'm missing about 20mm of depth. Which means if I cut my valve 20mm shorter, maybe it could work. First, let's try the emery. But even more first, let's take off the cutting tools before. Oh, don't know what happened to the tape here, but that wasn't the plan. So that didn't work, and of course the little piece of emery was stuck inside my valve body here, and it was of course a lot of fun to get it out. Okay, well, let's try a more primitive approach. I'm back here on the Celtic, where of course my future valve is still in the chuck. And I think my honing work was a success. Really nice fit, and it slides very freely. That's good. Right, all I have to do now is of course cut these features that I have on the old one here on the future one. The side I just finished here, this is of course the valve slide. And this longer part is only for positioning. And this smaller part here, this is a little bit rounded. This is of course the part that's sliding on the eccentric. But I don't see the need to cut it smaller. Maybe it looks good, okay. The total movement of the valve on the finished product is 15 millimeters, and this opening here is 20. So there's no need to make that much. So I made it 15. I think now I know why this little valve here has a reduced diameter on the shaft. Because, of course, I installed the thing here. When I spin it, I see that the valve itself is gonna touch the bearing. And now it works. To finish the valve saga, all that's left to do is to cut here this groove to let the air out. And as I see, this groove was cut a long time ago with the angle grinder. And I thought maybe I can do better and use the milling machine. But the thing is still installed at 14 degrees to make the micrometer, and I still need this setup, so I don't want to change it. Which means over to the shaper. Because on a shaper you can make whatever you want. Just do it. To center the tool on my workpiece, of course I cannot use an edge finder. So all I do, I bring the tool down and then, first I will take away a little bit of this maybe protection paper, makes it more visible. Right. Drag the tool around, make a little scratch. And now I can move left and right. Just a little bit, like this, is enough. Bring the tool back. And in the long line I made, now I see there's a short line the other direction. And I'm gonna center the tool on that little line. That's all. Total depth 0.5 millimeter. Because it is a very shallow cut, I will make another one 180 degrees apart. Make the part rotate on the parallel, and you can feel the click right there. Okay, let's do the other side. Both valves are now back installed and I think they're gonna work just fine. And now let's concentrate on the pistons and of course cylinders. When I take, for example, this one, seems to look good and it slides perfectly fine, but on the top side there is a little bit of play. And if I put my finger on the air inlet outlet is of course same, put my piston in, it works a little bit, but I think with the oilers on here, to be good, it should stay exactly where it was. Of course, as you can see, there are no piston rings on this thing. And if I leave the thing open, so this could work, but we'll see. The other one. Here the surface is a little bit more rough. And if I put my finger again here on the air in, air out little pipe, this looks much better. The problem is if I open air, it stays in place. So this one is a little bit too much stuck. I will clean it out and then reinstall on the machine here and then decide if I make new or if I keep these. This was one cylinder. So now let's do the other one. Compressor. All that's left to do now is to make a valve and a connection so I can put my air hose directly on the thing. And I think I have exactly what I need. A cute little leftover block with two perfectly useless holes in it and some other scrap here. And the plan is, if it works, to install this thing here. And because the hoses are in the way, I think all I have to do is to rotate this valve here and of course tighten again. So I have a little bit of room here on the side to put my valve. But first, let's build the thing. 2.5 bar pressure. That's not much. In my opinion, it works very well as is. I don't see the need to replace the cylinders and the pistons. The only thing maybe that I have to fix is this little hand crank thing to regulate the pressure. Because after all, we'll take it out. This thing is just a piece of bolt with 2 nuts and a little point on the other side. That's all. So make a little hand wheel. That should be good.